Welcome back. We are on Chapter 3, Visual Frequency Distributions, Looking at Data. Unit 1, we'll talk about how to present data on a table. Our objectives for this lesson are as follows. You will be able to define each of these terms: frequency distribution, cumulative frequency distribution, cumulative percentage distribution, and proportions and percents. GlobalDatingInsights.com found that more than 91% of surveyed college students use dating apps. In addition, 84% said Tinder is their favorite one. A researcher was interested in how college students use Tinder to date and how successful they were in meeting people and getting a first date. The sample consisted of 50 students, so we'll use this data set as an example for our definition of frequency distribution, cumulative frequency distribution, and cumulative percentage distribution. This isn't an exhaustive presentation of all the possible ways to present data, but it gives some of the most popular methods. So this data set is typical of the jumble of numbers we receive when we begin a study of any set of numbers. Our first job in statistical work is to organize the data and put the numbers in order. I'll refer to the numbers as scores, even though we don't typically use the word scores when talking about the number of first dates people have. If instead of a count of dates, these numbers had represented, say, raw scores on a spelling quiz or a short math test, we'd treat the data the same way. So the tabular methods I'm going to teach you can be used for virtually any data set. This is the tabular frequency distribution. The uppercase letter X is the symbol for raw scores. You can see that at the top of the first column. The lowercase f is the symbol for frequency. You can see that at the top of the right-hand column. All the numbers in the right-hand column provide counts showing how many students received each raw score, which is the number of first dates. Starting at the top upper left, you can see the highest obtained value was 10. At the top of the second column, the frequency column, you can see that one person made 10 dates. The lowest obtained value in the raw score column was 0. And this corresponds to a 4 in the right-hand column. Sadly, this means 4 people were unsuccessful and were not able to make any dates at all. Wah, wah. Notice I'm careful to use the word obtained because it is possible to receive more than 10 dates, but no one in this group did. So the 10 is the highest value on the table. At the low end, suppose no one had received fewer than 3 dates. If this had been the case, we would have deleted 0, 1, and 2 from the list of raw scores. This list of numbers would have started at 3 and ended at 10. So at the bottom of the right-hand column is the sum total of 50. If we add up all the people who received each raw score, we obtain the total sample size of 50 people. An idiosyncrasy in the table is the count for a raw score of 2. Notice the frequency or count entered for a raw score of 2 is equal to 0. There were no people who received exactly 2 dates. Sometimes statisticians leave this line out of the frequency distribution, but it's better to keep it in so there are no gaps in the table. This is the cumulative frequency distribution. As you can see, a new column of numbers has been added on the right side of the table, providing cumulative frequency. The symbol for cumulative frequency is CUM and a lowercase f, and it's in the header row of the column. Each row in the column answers the question, how many people received X or fewer dates? Look at the bottom number in this column. It's a 4. And this tells you 4 people received 0 dates. The entry above that is a 6, and this tells you 6 people received 1 or fewer dates. And you obtain this number simply by adding together the number of people who received 0 and the number of people who received 1 date. Moving up another step on the cumulative frequency column, you see we added no new cases. The cumulative frequency of people who received 2 or fewer dates is still 6. This is because no one received exactly 2 dates. Now look at the first column of numbers, the raw scores, symbolized as uppercase X, and look across the row for the number 4. 7 people received exactly 4 dates. You can see that in the column for frequency, labeled with a lowercase f. And the cumulative frequency, that's the number of people who received 4 or fewer dates, is 19. And that is how we read a cumulative frequency distribution. The entry for each row tells you how many people received this many or fewer dates, or if we're looking at scores from a test, we can say how many people earned a score of X or lower. Notice the entry at the top of the cumulative frequency column is 50. That's the sample size. No one received more than 10 dates, and 50 people received 10 or fewer dates. In the next table, we'll add another column called the cumulative percent. So in this table, the cumulative percent distribution, another new column has been added on the right-hand side of the table. The header for this column is CUM percent, the symbol for cumulative percent. The entries in this column answer the question, what percent of people received X or fewer dates? The value of X, recall, comes from the numbers in the first column of the table. For example, if we want to know what percent of people received 0 dates, we look across the bottom row of the table and we find 8% received exactly 0 dates. If we move up the column of numbers in the first column to the number 4, we can answer the question, what percent of people received 4 or fewer dates? Again, looking across the row to the last column, we find 38% received 4 or fewer dates. When we get to the top of the table, of course, we see that 100%, or all the people, received 10 or fewer dates. So how do we compute the cumulative percent? I'll show you on the next slide. The symbol for sample size is a lowercase n, and the symbol for cumulative frequency is CUM and the lowercase f. The formula for cumulative percent is cumulative frequency divided by sample size. This quantity is then multiplied by 100. If you don't multiply by 100, you'll have the proportion of people who received X or fewer dates. You need to take the extra step of multiplying by 100 to convert a proportion to a percent. So let's take a minute to review the concepts of proportion and percent on the next slide. So I want you to picture a number line in your head with low numbers on the left and high numbers on the right. Proportions are found in the range between 0 and 1 on the number line. Percentages are found in the range between 0 and 100. For example, if you wanted to express the ratio 1/4 as a proportion, it would be 0.25. Because that's between 0 and 1. If you wanted to express 1/4 as a percentage, it would be 25%. That's between 0 and 100. To convert a proportion to a percent, all you have to do is multiply by 100. To convert a percent to a proportion, you just reverse the steps and divide by 100. You can think of division as a way of undoing a multiplication problem. Multiplying by 100 moves the decimal point 2 places to the right. Dividing by 100 moves the decimal point 2 places to the left. So in sum, in Chapter 3, we covered frequency distributions provide organized counts of data. Cumulative frequency distributions answer the question how many people scored at or below a particular value. Cumulative percentage distributions answer the question what percent of people scored at or below a particular value of X. Proportions are written as fractions and range from 0 to 1. Percentages provide numbers that range from 0% to 100%. Chapter 3.1. Next up is Chapter 3.2, in which we'll learn how to present data on graphs.